You know the scene, right? It's 2 in the morning, you've just wrestled some critical system back from the brink, the alerts finally stop screaming, the crisis is over, and you can finally, maybe, catch your breath.
But then, as the adrenaline wears off, that nagging question starts to creep in. Could we have avoided this whole mess entirely? And that one question, right there, is at the heart of a massive shift happening in IT operations. We're talking about moving away from just fighting fires to actually preventing them from ever starting in the first place.
For years, the default mode has been reactive firefighting. A constant stream of alerts, those awful 2 a.m. emergency calls, just living in a perpetual crisis mode. But the goal is shifting, big time. We're moving towards proactive optimization, using predictive insights to build smarter, more reliable, and scalable systems from the get-go.
So what's the magic behind this transformation? Well, it's this incredibly powerful combination of two technologies: AI agents, which are like these tireless digital detectives, and large language models, or LLMs, which bring the reasoning and the smarts. Together, they are literally giving us the ability to see the future of our systems and stop problems before they ever affect a single user.
Okay, so let's pull back the curtain a bit and see how this all actually works. We're going to start with the core components that allow an AI to predict failures and, just as importantly, truly understand your systems.
At the very heart of all this predictive power is the data itself. Specifically, something we call MELT data. That's M-E-L-T, metrics, events, logs, and traces. You can think of these as the digital heartbeat of your system, the raw signals of its health. And AI agents are constantly listening to this heartbeat, looking for the faintest patterns that might signal trouble ahead.
And this is where that prediction turns into actual prevention. So imagine a service has been quietly, silently running near its resource limits for weeks. A human might not even notice it in all the noise, but an AI agent sifting through that MELT data flags it as a ticking time bomb. And instead of just waiting for the explosion, it recommends an adjustment, like maybe redistributing some workloads. The problem gets solved before it ever happens. But here's the thing. Just spotting individual risks isn't enough. Not anymore. In today's incredibly complex systems, everything is connected to everything else. To be really effective, the AI can't just look at one part in isolation. It has to understand the entire intricate web. This is exactly where a technology called topology mapping becomes absolutely critical. What it does is create a real-time dependency graph of your entire system. It shows you precisely how every single application, service, and database is connected. It's basically a living, breathing blueprint of your whole IT environment.
So why is this map so important? Well, think about it. A tiny, seemingly innocent change to a single caching layer could create this ripple effect that goes through the database, then hits the web service, and suddenly your whole environment is at risk. Without that map, you'd never see it coming. With it, the AI agents get what we call system-aware reasoning. They can see the whole picture and understand these cascading knock-on effects.
Okay, so we've got the raw data, and we've got a map of the system. Now it's time to add the brains of the operation, the LLM intelligence layer. This is the part that transforms all that raw data into sophisticated reasoning and, most importantly, actionable advice.
LLMs have a few key jobs here. First up is contextual understanding. They can read and actually make sense of all the messy, unstructured data that we humans create. Things like text-based logs, an engineer's deployment notes, or old incident reports, and they find the hidden meaning in all of it.
Second is predictive reasoning. By digging through mountains of historical data, LLMs can spot these really subtle patterns that a human analyst would almost certainly miss. For example, it might realize that a specific microservice only starts to degrade when there's a unique combination of high traffic from a certain region at a specific time of day.
And third, and honestly, this is the real game changer, they generate optimization suggestions. The AI doesn't just point out a problem and say, good luck. It actually proposes solutions. We're talking everything from drafting detailed step-by-step runbooks for your team to even generating the actual automation scripts you need to apply the fix.
Now, this isn't some one-and-done kind of fix. The real power here comes from creating a system that gets smarter and smarter over time. And that happens through what's called the AI learning loop. It's this powerful, continuous cycle. The system first observes every incident. Then it analyzes for patterns. Next, it acts to fix the immediate issue, and finally, it optimizes to make sure it doesn't happen again. So with every single cycle, the system doesn't just get repaired, it gets smarter. It transforms from just a reactive tool into a truly adaptive one.
So what does this actually look like in the real world? Let's make it concrete with a really high-stakes example. Managing a real-time financial transaction system, where even a second of downtime is just not an option. So here's how it plays out. The AI agent predicts a bottleneck is about to happen in the transaction service. Using the topology map, it instantly sees that this will impact other critical systems down the line. The LLM then jumps in and generates a recommendation, maybe to scale the service or rebalance the load. And finally, that fixes it's implemented automatically or sent to an engineer as a perfectly clear runbook. The key here? The problem gets solved before the traffic surge even begins. No alarms, no downtime, and absolutely no firefighting.
This proactive approach isn't just a small improvement. It's a completely new paradigm for how we manage systems. We are finally truly moving beyond the era of constant firefighting and into a future of intelligent, adaptive systems that are built to scale.
This idea really captures the ultimate goal perfectly: to move beyond firefighting and create systems that are reliable and capable of scaling. It's all about building systems that learn from their own mistakes, which frees up our human teams to focus on innovation instead of just, keeping the lights on.
And this all leaves us with a pretty fascinating question to think about as this technology evolves. What happens when our systems get so good at predicting and preventing issues that they can fix problems before we even know they exist?